Exactly. Here we go. Thank you, Alana. So great. Well, welcome everyone to our monthly EaRTH webinar series, and which is also today going to be co-sponsored with the program on reproductive health and the environment. Before we get started, because we really want to spend all our time talking with Shanna Swan, we're very delighted to have with us. I want to just make very short announcements, which is for people who are in the EaRTH Center, we are offering small seedling project awards, so resources, up to $20,000 worth of services from the EaRTH Center with a focus on biomonitoring services. So as everyone knows, Junsu Park, who's at DTSC, his lab is open and we have he's offering services, and Jennifer Fung's chemical screening library. Both those are on our website, so please apply by May. Just to announce something that's happened since our last meeting is that we announced that we were offering 2 free awards to the Environmental Justice Boot Camp that we're co-hosting with Columbia and Harvard University, and Yogi Henlin and Jessica Trowbridge will be attending for free on behalf of the EaRTH Center. So congratulations to them. And now I am going to introduce Shanna Swan, our speaker for today. So it's really a pleasure to have you, Shanna, because people probably know if they're on social media or read the news or look at Mick Kristoff that she has recently published a book called Countdown, which is based on her long and extensive experience in looking at sperm quality, reproductive health, and the role of environmental chemicals. So she's one of the world's leading experts on environmental reproductive health, and she's an epidemiologist and a professor in environmental medicine and public health at the Icahn School of Medicine in Mount Sinai in New York City. And she is going to be talking about her work in this area. And please, people, if you have questions, I know Shanna will take them. She's super expert now because she's been doing so many excellent interviews. And we're really lucky to have her because she's going to be a famous movie star soon. So fortunately, she came to speak to us first. And if you have any questions, put them in the chat. She's going to talk, and then we're going to take questions afterwards as well. So I'm going to turn it over to you, Shanna.
So thank you, Tracy. And I'm really thrilled to be here. And I've had a very warm attachment to UCSF. I have an ongoing study that I'm no longer PI of because I've given that to somebody else, but one of those centers for TIDES is here at UCSF, and I'm so excited to be able to share these results with you and talk about the book with you. So let me start my presentation. I'm going to go to share my screen, and so the title of my book is Countdown: How Our Modern World is Threatening Sperm Counts, Altering Male and Female Reproductive Development, and Imperiling the Future of the Human Race. Not a small subject, and I hope to convince you that it is the research is worth that title. Okay, so thank you to EaRTH and to Pre for bringing me here and allowing me to share these results with you. So I'm going to talk today about these 4 steps, if you will. This is the roadmap for my talk. So I'm going to talk about the problem and its causes, consequences, and solutions. And let's start with the problem. So as you can see here, Houston, we have a problem. This group of scientists at NASA are very aware of this problem and are working hard to solve it. And we really need to have the same kind of attention drawn to the problem that I'm going to talk about, because at this point, it does not have this kind of focus or attention. We did get quite a bit of attention back in 2018 after we published our meta-analysis showing, as GQ said, an extinct possibility, and revealed, quote, the truth behind the shocking drop in sperm counts. And that was the paper we published, which included or presented our meta-analysis of sperm decline. But this was definitely not the first paper that had looked at trends in sperm counts and concentration. And I think the first really important one of these was published in 1992. And this study was out of Copenhagen, University of Copenhagen, first author Elizabeth Carlson. And this paper really was shocking at that time. It was the first paper that had said there has been this genuine decline in semen quality over 50 years. And the 50 years that they covered, it's actually 53, I think. Over that time, sperm concentration had dropped just over 50%. So that's about 1% per year. And I'd like you to keep that in mind because actually that rate of decline has been seen since that 92 paper. But when I first saw this, and by the way, the circles are proportional in area to the log of the sample size. If you're wondering what those circles are, those are the studies, and that reflects the size of the population. And so when I first saw this, I was on the National Academy of Sciences Committee on Endocrine Disruptors, and the committee wanted to know whether they should take this seriously in their deliberations. And actually, I have to say, I did express my skepticism about this paper. Kind of embarrassing now, but there it is. And so they asked me if I could look into it. And because I was on leave from the California Department of Health, where I had been working for quite a while, I had the time to look at this in depth. So let's just stop for a minute and think. Many of you are epidemiologists or know epidemiology, and you can imagine that there could be some biases and confounders that could produce this decline, even though it wasn't real. For example, changes in method of counting sperm, right? I mean, if you counted more recently using methods that gave you a lower count, that would make it go down. If the men who came in more recently were more likely to be having lower sperm count, maybe there were men with problems and that brought them in, selection bias, right? Or maybe confounders like obesity or smoking or aging or stress, or, you can think of a lot of things. So what I decided to do was to go in depth to the 61 studies underlying this and see if I can make this trend go away. Could I explain this by biases and confounders? And so when I finished that analysis, which actually took almost 6 months, I had really, the surprising conclusion that the slope to the first decimal place had not changed at all. So I had to rethink my skepticism and think about whether perhaps this was real. And if it was real, what could cause it? And that's when I launched my studies on semen quality in 4 cities in the United States. And it also led me to re-examine this question in subsequent analyses. So here is the original analysis by Carlson. Here's my publication 2000, in which I separated these studies into those by geographic region. And let me say that throughout these studies, almost all the data comes from Western countries, North America, Europe, and that's because there aren't very many studies in other countries, unfortunately, although they are now increasing. So if you actually put these lines together and average them, you'll get something very similar to the Carlson decline. And then if you look at our results from the 2017 paper, you'll see from something very similar. So the red line is unselected Western men. Well, Western means Europe and North America, Australia and New Zealand. Unselected is men who don't know their fertility status. And these tend to be young men, men being examined for the military, and so on. The fertile Western men are men who are fathers or soon to be fathers, partners of pregnant women. And then the blue and the yellow are other countries for which we had very little data, and actually nothing was significant for other countries. Okay, so it's not actually just a problem of sperm count or here we show concentration. Count is concentration times volume. There are many other male parameters, but there's also the question of fertility, which is a male-female combined effort, if you will. And then there's female problems. So before I get to that, let me just say the decline that we showed which was from 99 million sperm per milliliter to 47 sperm per milliliter, very dramatic, could not extend indefinitely. And I want to stress this because people say, well, when does it hit zero? In fact, it cannot hit zero. And if you think about this, I have to tell you, these are medians. These are medians. That means half the men are lower and half are higher, and you can't have a negative sperm count. So this line was drawn by actually a colleague, and he just said, well, when does it hit zero if you were to extend it? 2045. Could it get there? No. And so we're going to talk about ways to make this line veer off with improvement in our environment. So now we're going to talk about primarily males today, but I wanted to point out that there are lots of problems in females. I don't have time to go into them today. I'll mention one or two of them. And infertility, which is, of course, a joint effort and which has also been going down. So here's are some comparison of slopes, if you will. 1% per year in sperm concentration in Western countries. But interestingly, birth rates, number of children per woman or couple, has declined worldwide at the same rate. This is kind of surprising. It was 5 children back in 1960, worldwide was the average, and now it's under half of that. So that's a 50% decline in a little over 50 years. Miscarriage, we have less trend information on. This is one study that looked at the increases in miscarriage rate, and that is also, if you calculate it, about 1% per year. So I call this the 1% effect. And if you look at other changes like testosterone and increases in hypospadias, testicular cancer, and increases in premature ovarian failure and so on, the rate at which these things are going along is about 1% per year. And the fact that these are sharing this common, if you will, pulse is pretty interesting and suggests some common etiologies, although of course does not prove that. So what could be causing this 1% per year decline? So I'd like to step back and just say, I started with separating all possible causes into genetic and non-genetic, and I'm calling non-genetic environment, recognizing, of course, that we could have gene environment. Genetic changes are not going to explain these, genetics is not going to explain these changes of this magnitude over 2 generations, which is what we're looking at with 50 years, right? And so if we look to environmental causes, I've broken those down into chemical and lifestyle broadly. And I'll say a word about lifestyle factors. So lifestyle factors, I'm not going to spend a lot of time on, but they're really important for our reproductive health as they are for our overall health. And just, I'm showing images for diet, which is important and shown to be linked to, among other things, semen quality, as has binge drinking, stress, heat, obesity, and lack of exercise. But it won't be lost on you that these lifestyle factors are lifestyle factors for our overall health as well as our sperm health and our reproductive health. That said, I'm not going to talk a lot about these lifestyle factors in this talk, although I have done studies on each of these lifestyle factors in relation to semen quality. So now I'd like to turn to chemicals and specifically endocrine disrupting chemicals. And that's particularly important in this context because I'm talking about reproductive health. And of course, chemicals that can affect our body's hormones, particularly our steroid hormones, are going to be intimately connected to reproductive health, right? So I'm just listing some categories of EDCs here, and I don't have time, obviously, to talk about all of them in relation to reproductive health, but all do have implications for reproductive health. And I've studied actually a number of these, but today I'm going to concentrate on phthalates, where most of my work has concentrated. So before I go on to phthalates, I'm sorry, I jumped the gun here a little bit. I wanted to just mention these other sources of endocrine disrupting chemicals. So Teflon, anything, any barriers, such as Teflon coating, water resistance, oil resistance for paper, any kinds of coatings, soft plastic containing phthalates, flame retardants in the home and cushions, carpets, and other products, pesticides, bisphenols in tin cans and cash register receipts and pizza boxes and lots of things. And finally,
oh, great.
Or you want to
Get my text? No, I can get off this.
I'm sorry?
I believe somebody's not on mute,
Okay.
but I'm sure Alana's taking care of that right this minute.
Okay, thank you. And nail polish, just go back, I just didn't finish that sentence. And nail polish also containing, among other things, phthalates, because these are in there to retain color and scent, among other things. So plastics are very central to the story of phthalates and also bisphenols. And I just wanted to point out that we're talking about a 50-year decline, and that's just about how long these products have been accumulating in our environment at an increasing rate. So now I'm going to hone in on the specific issue of testosterone and male reproductive development, where I've spent a lot of my research, energy, and time. So I'd like to, first of all, point out this is a cartoon, if you will, just a schematic, but it's to make the point that initially the sex organs are undifferentiated. They're similar, they're the same in males and females, whether it's humans or other primates. And the introduction of testosterone in early pregnancy causes the differentiation of these sex organs into male, that is genetic male typical, and female sex organs. So testosterone is playing a really critical role here. And what can interfere with testosterone? Well, it turns out there are several phthalates which are strong anti-androgens or testosterone lowering. And those are, just to give you the alphabet soup, if you will, DEHP, diethyl hexylphthalate, dibutylphthalate, DBP, and BBZP, benzyl butylphthalate. And now more recently, DINP, which is a substitute for DEHP. So, and others to a lesser extent. So these, which are found, of course, in nail polish, as I mentioned, shower curtains, and surprisingly, perhaps in milk, and other foods, because of the tubing that foods pass through on the way to our table. So what happens when testosterone is decreased? Well, here's a picture of a study that was published in 2000, which showed really nicely that in a rodent, when the mom was exposed to DEHP in a critical window during development, that the testosterone surge that was expected, shown on the left, was depressed in the presence of DEHP exposure. That testosterone surge in this animal model was completely suppressed by administering diethyl hexylphthalate. And remember that this testosterone surge is really needed for the differentiation of those male genitals. So what was shown shortly after that study was, more generally, when DEHP and other androgen-lowering phthalates were given to the mother during pregnancy at that critical window, then the males were born with something which was termed the phthalate syndrome. So let me stop for a minute and ask you to think about this, and think about whether, because I'm asking you because I'd like to know if anybody's heard of another syndrome other than fetal alcohol that's been associated with a prenatal exposure. I don't know of any, and to me, it's very important because it really emphasizes the importance of these changes. So the phthalate syndrome in animals was initially a smaller penis, a malformed penis that could be hypospadias or cryptorchidism. Hypospadias, undescended testicles, or cryptorchidism, and then a shortened anogenital distance. Now, I think probably many people on this webinar will know what shortened anogenital distance is, but let me step back and say anogenital distance is a measure of perineal length, and it's something that's referred to on the street as the taint. Somebody, when I was talking, said, "Oh, you mean the taint length?" And so I started using that term because it was more familiar. But actually, the anogenital distance has been used for a very long time in rodent studies. I found a paper from 1912 in which it was used, in which it was demonstrated what I'm showing here is that it's much longer in the male than in the female. It was used to sex pups after birth. And then it was used in animal toxicity testing. When you were looking for reproductive toxicity of a new chemical, you'd look for the anogenital distance. So it was well known, but nobody had used it for what I call human toxicity testing. So one question that comes up is, could phthalates be doing this to humans because the doses are so small that we're getting from our shower curtain or our milk or our cosmetics? Yes, we're getting low doses, but I just put this slide up to remind you that the developing fetus is extremely sensitive to very, very low doses. And there's a beautiful literature on the called the testosterone transfer hypothesis, showing that very small changes in testosterone in utero do lead to significant physiologic and behavioral changes later in life. So I asked the question, is there a phthalate syndrome in humans? Seems like a natural question. And to do that, you have to, of course, measure phthalates in the mother during pregnancy. And then you have to relate that to measurements in the offspring, in this case, the male offspring. So fortunately, one of the studies that I had set up earlier, in particular one to look at semen quality in 4 cities in the United States, called the Study for Future Families, I had actually stored urine from pregnant women in that study. At the time, I didn't know why I was storing it, but I thought, well, it's cheap. And by the way, I recommend whenever you can that you store urine because it's easy to store, it's cheap, and it's very, very useful. And so we had these urine samples and we could send them to the CDC once I got a grant from NIEHS to do this. And that was 1/2 the equation. And then we had to examine the offspring and look for the phthalate syndrome. Now, this had never been looked for in humans. So it was a bit of a challenge to figure out what was the exam that would mimic the rodent exam in humans. But with the help of colleagues and some pediatricians that say what they look for in terms of masculinization of infants and so on, we designed a study and began to measure these outcomes in our male offspring. And what we found was the phthalate syndrome. So we published this in 2005, actually not on our complete data set. Then we extended that in 2008. And then I felt it was really important to do this again and to do this carefully. Remember, the first study was not designed for that purpose. It was not a hypothesis testing study. So our second study, which is called TIDES, which actually has a center at UCSF and for which we are still following the children, thank goodness, which is part of ECHO, that study examined the phthalates at 3 points in pregnancy and also examined the children right after birth which is what is done in rodents. So it came closer to mimicking the rodent study. And there again, we replicated the finding of the phthalate syndrome in humans. So let's stop for a second. I think that's a big step we went through, right? There was originally the mechanistic studies showing that these phthalates were anti-androgenic. Then they were tested in animals repeatedly. The phthalate syndrome demonstrated, and then we demonstrated this in humans in 2 studies. And other people, by the way, have demonstrated this further in humans. So I think we can say, my first statement, prenatal phthalate exposure causes the phthalate syndrome in human males. And I'm using that word cause very deliberately here because of the mechanistic and animal backing to the human studies. And we know now that phthalates are anti-androgenic. We know they're endocrine disruptors, human endocrine disruptors. And we know that AGD is a marker of fetal androgen exposure. Now, this is only the male part, but without going into it, I can tell you that on the female end, we also see what excess androgen being related to longer female anogenital distance. So it's a marker of androgen exposure, both over and under, depending on the sex of the child. So I think AGD is important. It probably should be measured at all births, in my opinion. And it is now measured in tens of 20,000 births around the world. And we've published some normative data. But why do we care about AGD? Let's stop there and think. These children don't look malformed. Changes are very subtle. You have to use very careful measurements to show these differences. So what I then asked is, well, what does this have to do with reproductive function? And these were children, babies. They didn't have any measurable reproductive function. And in order to wait for that, I would have to wait 20 years. So because I really wanted to answer that question right then, I started thinking about how to do that, and again went back to the animal studies and the evidence from animal studies that AGD is a permanent marker. So that if you're born with a short AGD, the chances are, according to the animal studies, that you'll have a short AGD for your size throughout life. Now, I have to just say, frankly, we haven't really completed that link. We really do have to follow our children until they're in their 20s and we can look at their reproductive function and their semen quality. But let's assume that's true for now. And then you can say, okay, if that's true, then a man with a short AGD should have a low sperm count. So in order to look at that hypothesis, I conducted another study, and that was in Rochester, New York, where I was living at the time. And we got young men to come in, 18 to 21, college students, and give us a semen sample and let us measure their AGD. And what we found was pretty dramatically that the shorter the AGD, the lower the sperm count. I wanted to point out that this sperm counts below 40 are special in a way that when you get down there, you are having a longer and longer time to get pregnant. The monthly probability of conception drops off quickly below 40. And you see here that these men with low sperm counts below 40, right? They're most of them in the short AGD part of the curve. And so a colleague in Stanford, Michael Eisenberg, also showed that this was related to infertility, that infertile men, particularly those who had never fathered a child, also had shorter AGD. And other studies have shown that children with genital defects also had shorter AGD. So it looks like the entire male reproductive system can be altered and measured by AGD, and probably all of it responding to anti-androgenic phthalates. Okay. This slide is here to make you think about timing, which obviously is extremely critical in this situation. And I want to talk about the criticality of timing for our exposures that we're looking at. So I mentioned that there was a narrow male programming window that's called the MPW, and this is in rodents, and it's actually 3 days long, which is amazingly short. and very precise. To find this, of course, they had to treat the males at different times. And in fact, if they're treated before day 15, the AGD is not altered, the phthalate syndrome is not produced, nor is it above 19 days. So what about humans? Well, we couldn't administer phthalates at different times in pregnancy, obviously, but we could get multiple urine samples. And we got 3. And what we saw was that it is indeed the first trimester that's sensitive for the development of AGD in humans as well as in rodents. The other way that timing is important is illustrated in this slide, which is actually about smoking, because I don't have all this data on phthalates. And some Danish studies showed that when the father smokes around the time of conception, the son has about a 40% reduction in sperm concentration. I'll just remind you that sperm are being produced all the time, takes 70 days. So in that 70-day window, preconception, damage to that sperm can affect that pregnancy. And when the mother smokes in the first trimester, her son can have a 40% reduction in sperm concentration. Those changes are irreversible. Those are structural changes that cannot be repaired. However, if the man himself smokes, he also reduces his sperm count, not as much, and in a way that is not permanent. If he stops smoking, he can regain his sperm health. So timing is really, really critical. And I can't stress enough that the critical period is for reproduction during the first trimester. Okay, so now let me talk about a few consequences of these exposures. Perhaps the most surprising consequence is that low sperm count is associated with earlier death. There are a number of studies now showing this, and I think it's a reflection of the fact that low sperm count is a reflection of other changes in the body, lowering of androgen, which can also affect other developmental systems. And it's not, I think, the actual production of sperm itself that's related to mortality, but these other conditions. But in any case, this study out of Denmark shows that in men without children and with children, to a lesser and a greater degree, their risk of death increases with a lower sperm count. And notice that all of these values are below 40. And I told you that 40 was a really critical division for sperm concentration. And when it's above 40, there's not much of an effect on mortality, but below 40, where we are approaching, by the way, if you think of the declines, we're getting to the point where sperm concentration in men is going to possibly lead to their earlier mortality. So this is a pretty important life consequence. And it has led people to suggest that perhaps we should consider reproductive health as one of the 6 vital, the 6th vital sign, because just like you get your cholesterol checked and your blood pressure checked, I think men should get their sperm count checked because it's going to tell them something about their overall health. And another consequence, which I don't have time to go in today, is the reproductive health and survival of multiple species on the planet. And all of these animals have their reproductive system impacted, and several are endangered, and they are not electing these exposures. We are actually dosing them inadvertently. And I want to point out that the exposure is not just to the mother or even just to the fetus she's carrying, it's also to later generations. And the number of generations is still under discussion, but certainly we know that the 3rd generation is the germ cells are contained within the fetus, and those germ cells are also exposed to the chemicals that the mother is exposed to. So certainly we have effects at this level and perhaps further. Okay, so now let's go back to this and think about how we could avert this decline below 40. If you continue this, we are now right here at 2021, which is 10 years after the end of our study. And if it's declining at 10%, at 1% per year, we've declined 10%. So now we should be down at 37. In any case, we should be below 40 average in Western countries. We're already at the point where it's getting harder to conceive and where the impact on life expectancy may start to be seen. So in order to avoid this scenario, and by the way, surrogacy is also increasing at a similar rate, I think we have to talk about some solutions to this problem. Now, one of the most positive things I've heard comes from Pat Hunt at the University of Washington. And what she did was she took animals mice actually, that were exposed to estradiol, and at the highest levels, they were most impacted. The father was directly exposed to estradiol. The son was only indirectly exposed in utero. The grandson was unexposed. The great-grandson was unexposed. She kept their environment extremely clean and free of endocrine disrupting chemicals. And she says, in 3 generations, you can turn this around. So that's actually pretty encouraging. We're looking at a lot of short life chemicals and ways, we're starting to look, as you all are in ways to keep these out of our environment so that we can reverse these really dangerous trends. And just some specifics. I'm sure many of you know, if not all of you, that we're in the process of regrettable substitution, where one hazardous chemical is swapped out for another. For example, you want to buy a bisphenol A free bottle, you can do that, but you have no guarantee that that is bisphenol free. And it's very likely that it contains an alternative bisphenol, such as bisphenol F or bisphenol S. And that's pretty, insulting, if you will, to the consumer, that they think they're buying this product that's become safer when it really hasn't. A way to get around that, of course, is to do something different than we're doing now in terms of regulating chemicals. So we are really, in my view, still like rats in cages exposed to these chemicals, being part of this vast experiment that we haven't really agreed to. And we can change that by testing chemicals before they're put into the market. So here's what I think we have to do. We have to remove hormonally active chemicals that cause harm at low doses, because remember I said briefly that low doses could be harmful. And in fact, that is absolutely true for anything in the endocrine system. It can have effects at very low doses. We have to remove those that are environmentally persistent and those that are untested, which are in the tens of thousands at least. And we have to replace those with chemicals that are without endocrine disrupting effects, that are free of low dose effects, that are minimally environmentally persistent, and perhaps most importantly, shown to be safe prior to marketing using a REACH-like set of regulations as they have in the EU. And I just want to mention a little fact that, for example, there are 1,100 chemicals banned from personal care products in the EU and 11 in the United States. So we can do a lot better. And to make that happen, we're going to change our regulations. And we have to regulate at low doses. We have to regulate at a human relevant scenario. We are exposed to low doses. We are exposed to mixtures. And we have to deal with assessing the persistence of these chemicals in our environment. And then we have to test the untested chemicals. So I'm going to stop and thank NIEHS and US EPA, and then all of our participants, some of whom are here at UCSF, and our study staff, and I'll take questions and suggest you buy Countdown, by the way. Of course, I have to plug my book. Thank you.
Thank you, Shanna. That was terrific. And I know all that stuff and it's still interesting every time. So people can, I'm looking to see how people can put stuff in the chat or, I just have a question, but I can't remember. Could you comment on the female fertility? Oh, I had two questions. One is, could you comment on what's known about female fertility? That's my first question. Then I will wait and see if somebody else has a question and then ask my second if I don't hear that.
Yeah, so I see fertility as a joint venture. So when I think about fertility, I think about the combination of male and females together. But aside from that, there is definitely an increase in diminished ovarian reserve, in problems that are related to female when the female is identified as the cause of the infertility, those causes have increased in endometriosis and so on. So, I work mostly on the male side, and I haven't actually personally studied. What?
I did do that very nice letter about the NHANES from the Reproductive Health Questionnaire, looking at difficulty in conceiving and maintaining pregnancy, right, across the different temporal trends.
Right.
So,
Yeah, I did work for a long time on miscarriage. I have to say that was actually my introduction to reproductive epidemiology, where I studied the environmental causes of solvents and chlorination byproducts. But I haven't studied these particular chemicals in relation to, say, miscarriage risk, or, so definitely they'll be contributing, and but I don't have the data to talk about exactly how that's happening.
So we had a question about reproductive or chemical, sorry, I'm going to just scroll back, chemical exposures compared to these lifestyle factors you talked about. Maybe you could say a little bit more about that, and maybe in addition, what might be other chemicals that are like that are like phthalates, that are testosterone diminishers. So
right. So, separating out, maybe doing attributable risk for the lifestyle factors and the chemical factors, that actually, I haven't actually seen that done. If you look at the entire, ball of risk, modifiable risk factors, lifestyle factors, and the chemicals, I actually don't know how to parse that out, but I do know that the lifestyle factors are tend to be more important in postnatally. So, the big hits that we see are the prenatal exposures to the endocrine disrupting chemicals. Then, in addition, you can add on, like I said, smoking, changing sperm count. You have phthalates, changing sperm count. It's hard to separate those out, and I would say probably the lifestyle factors are more important postnatally, and the chemical exposures are more important prenatally, but I can't put a number on it at all.
So you would admit, Shanna, that, smoking being a great example where, not that it's, for example, in California, less than half the people smoke, but everybody's exposed to phthalates. So you have to think about that part too, in terms of
in terms of population burden. Absolutely.
Okay.
And pregnant women don't smoke. Pregnant women don't hardly smoke at all anymore.
Right. Pregnant women don't smoke. So in that case, right. I'm going to try and read. The association between risk of mortality and sperm count. That was people were really interested in that. Can you talk a little bit more about why you think sperm count is a readout of health state, or whether subfertility is actually a determinant of health?
Yes. So what is increased in men with low sperm count seems to be, among other things, I'm sure there are other things, but heart disease, diabetes, reproductive cancers, particularly testicular cancer. So those are three, sort of important. Well, testicular cancer doesn't have huge impact, not great numbers, but certainly diabetes and heart health are very important, and they are associated, they are lower in men with lower sperm counts. So fertility is a really interesting measure of overall health. And actually, one of the international societies, as I mentioned, came forward and suggested that this be thought of as the sixth vital sign. I don't know if you were part of that, Tracy, or not. I think Linda Giudice
maybe Linda was on it now.
Yeah. And, you know, recognizing that fertility is a marker for overall health, I think is really, really important, and might lead people to talk about it more, accept it more, not take it for granted, which is, I think, one of the problems in this area, that people don't talk about their reproductive health. They don't know it, even many of them, until they have a problem. And then, you know, it gets harder to do something.
Well, do you think there could be that it's a marker for testosterone, and then that's the link to the poor health quality later?
Yes, that's exactly what I think. I think that altering testosterone in early pregnancy, or actually later for other outcomes. So we also found links between the phthalates and behavior, right? And other people have done that as well. So later behavior, we found there was actually a relationship to what is probably differentiation of the brain, in, you know, sex differentiation of the brain, by looking at play behavior in our kids' relation to phthalates. So there's just a lot of consequences of messing with testosterone levels and timing of testosterone in pregnancy.
So you mentioned many factors for studying reproductive toxicity. What do you think are the most defining, is this question, or important?
Can you ask me again? Because I didn't hear the first part. Is this on the chat? Or is this your?
Yeah, Jennifer Fung. Well, maybe she wants to ask. Jennifer, unmute yourself. I see you there.
Okay, so I just wanted to ask, like, you know, that you can measure hormone levels, various hormone levels. You can measure your AG distance. What sort of factors are the most important for defining a reproductive toxicant? Like, is there one measure that people can use that then, you know, you can compare across studies? Because from what I'm reading now, they're all different. Everybody does a different one.
Right. Well, if I had to pick one, I would say I would take. Well, you can't measure fetal testosterone, can you? So what AGD is a measure of fetal testosterone. It's a readout of your fetal testosterone. Let me just convince you of that, maybe try to convince you of this on the female side. So females with PCOS, you know, have higher testosterone, and their girls have a longer anogenital distance. Okay, so on the female side, maybe too much testosterone during that critical development leads to masculinization, if you will. And also girls with CAH, congenital adrenal hyperplasia, have excess testosterone. That is reflected in a longer anogenital distance. So I think of AGD, anogenital distance, as a way of looking into the black box of the fetal environment and getting a measure of how much testosterone was present. So when you say, is it testosterone or is it HD? For me, they're the same operationally, because we can't know the testosterone in utero, but we can know the AGD.
Thanks.
So just to revisit your figure in the beginning of the talk, you know, showed you decline in the number of children overall, right? The size of families, and that this is also concurrent with declines in sperm count and increasing chemical production. Can you comment on another factor that might be contributing, which is the cost of children, or, you know, decline in women, you know, the whole argument.
Sure.
Older, having children, choice, yeah.
Right. Well, I certainly would not say that the decline in the family size or the fertility, or technically the number of children per woman or couple, that is only due to chemicals. Absolutely not. However, and what other factors I mean, I'm sure you're all aware of this, the delay, voluntary delay in childbearing, which is associated with increased availability of contraception, urbanization, economic status of women. All of these things are contributing to this. However, it's not the whole story. And let me just say 2 pieces of evidence for that. First of all, there are declines in fertility in women 25 to 35. And in a Danish study, women in that age group had lower fertility than their grandmothers did at 35. Okay, so it's not just older women who have delayed their childbearing that's having trouble having children. Okay, and the other thing to point out is that fertility is declining in multiple species around the globe, and they are not choosing to delay their childbearing. So I take a lot of
This just means you have to update your data again from NHANES on those. Remember, you found that the young women, their ability to conceive and maintain their fecundity was decreasing over time, and they're the most fertile group of
right
women. So
right.
there you go. It all comes back to your excellent work. So that actually raises another question that somebody asked, which is, how big do you think the proportion of known EDs, the things that we already measure, like phthalates and bisphenols, explain anti-androgen effects compared to the unknowns that are out there, which, as you know, there are thousands, and they could be a greater anti-androgen effect? This is like a trick question.
I love that. I love that question.
We don't know if we're going to be contributing.
I love that question because it allows me to talk about one of my new interest areas, which is paracetamol. So paracetamol, Tylenol, acetaminophen was discovered to have very similar chemical structure to diethylhexylphthalate by a Danish researcher about 10 to 15 years ago. And there have been a series of studies showing many of the same changes that we saw associated with phthalates to being associated with paracetamol. And so this just to say, yes, there are likely tons of anti-androgens we haven't identified. On the flip side, we have a paper we just published which showed that the pesticide glyphosate in Roundup is associated with a longer AGD in females, which makes it an androgen. Okay, so we're just discovering, maybe we've just even scratched the surface of discovering these chemicals that are wreaking havoc with our reproductive health.
Well, actually, somebody asked a question about a solution. Can you comment on how effective becoming a vegan might be for reducing your level of exposures? I feel like you did a study about this with the Amish community. Was that you?
We did a study with the Amish community, but we didn't actually tie it to their diet. So I don't actually know. We did, let me just say, because you brought it up, it was very interesting, a very small study, but that they make their own clothes, they build their own, everyone knows what the Amish do. Right? This was Old Order Mennonites, actually. So, but similar behaviors. And they had very, very low levels of exposure to the chemicals we measured, which I think was phthalates and bisphenols. And the exceptions were notable because we saw a blip from a woman who had used hairspray that day, and they're not supposed to use hairspray, but we saw it and we saw a blip from a woman who had ridden in a car, because they don't ride cars, they ride horse buggy, right? And so definitely in that community, you could see the effect of individual exposures. But as far as a vegan diet, I don't know, but I do know that eating unprocessed food will lower your exposure.
Didn't you do I thought you also did the study with the Buddhist monks who had a vegetarian diet? That was another one.
Not me.
Was that you? No. Okay.
No.
So the question is, do you think it would make sense that vegans have lower levels of chemicals? Yes, right, because you don't eat animal byproducts and a lot of these chemicals,
right,
particularly love fat. They love
Right.
the fat of animals, and animals are exposed to the chemicals.
And also
Or-
people who are vegan will take more care with their food. And I think probably will be more likely to eat, organic food and unprocessed food and so on. So these are things that will lower your exposure. So they're correlates of being vegan, if you will.
That's true. Well, I want to thank you, everyone. I think I've gone through all the questions. So there are comments about how amazing your presentation is, and that people are purchasing the book or have purchased the book right now. So I
Yay!
I don't even plug products. So there you go. Yeah, thank you, Shanna. It's really a pleasure to have you. And I know you used to be here in the Bay Area with some of us. So we're so glad that you're here again to talk about your really important work. And thank you, everyone, for attending.
Thank you so much, Tracy. It's been a pleasure. And thanks everybody for your questions and for your participation and your interest in this problem and my book. Thank you.
All right, thank you.